All right, this is Sparks Pre-Calc. This is day number 7. And we're going to talk about domain and range. So to define the domain is the set of all x values. Defined for a function. Range is the set of all y values. Defined for a function. Alright, so let's just jump right in. So we're using interval notation, the domain and range for each function. So we want to go find the very smallest x value. And so for me, I kind of use my pencil as a guide, and I go over here and find the very last place to the left where that function exists. And it happens at -4. But it actually doesn't exist at -4. This is an open interval, -4, because it's open. Now we go along our function, and now to find the biggest x value, we go along the function, and we see this arrow right here, which says it's going that direction forever and ever in that same pattern. So it is increasing, x is increasing, y is decreasing, but x is increasing, so it's going to go to largest x being infinity, and we can never actually touch infinity, so it is also open. We talk about the range, we do the same thing, but now we're going from bottom to top. So find the very smallest y value, and that arrow gets in our way and says that it's going forever and ever. -infinity is the very lowest part that it gets. And then we look for the highest part, and that happens over here at this open value at 5. And it's open. Let's see this one, the domain. If I start with my smallest x values, that's going to be forever and ever, so that's -infinity. And as I go to the right, and I see right here at 1, it is not defined. There's an open circle, so I have to put 1 and close it. But then I open it right back up and say, but it exists everywhere but 1, so we're going to start at 1. And this arrow says it goes forever. Same thing with our range. Our very lowest value is going to be -infinity, and it gets up to +1, 1 up. Oh, but check this out. We start to disinclude it, but look what happens. Right there's the value 1. So we're just going to change this to say infinity. So even though it was open right there, this point over here fills that in. So we can't see it. So it's all real numbers from -infinity to +infinity. Alright, so this one's a little different in that it has some jumps, not just gaps or holes, but actually jumps. So the domain, we're going to start to the far left and see the smallest value. It's a arrow, so it means it's going to start at -infinity. And then we get here at 1, we have a hole that gets filled in by this. And then it starts over where we have a hole, and going all the way, this arrow tells us it's going to +infinity. But when we talk about the y values, the range is a little different. The very lowest one is -3, but it's not equal to. And this arrow tells us it's going forever and ever and ever in that direction. And even though this is a point here, there's also another point over here. That should be a comma, sorry. And that's going to go forever and ever and ever. And even though this is open, there's a spot over here that closes it. And then they both go forever and ever to the positive direction. So the range is -3 to infinity. Okay, I'm not going to do all of these, but I am going to do at least this one, because this one does have some gaps that we have to address. So domain, we start on the left, we have an arrow. That's going to start at -infinity. And then right here, this one doesn't get filled in, so we're going to stop that at -1. And then there's our or symbol, and then it goes from -1, it's continuous, until we get to 5. So -1 to +5. And again, we had to skip a value. We skipped it at -1. Then our range, let's see, lowest value. No, the lowest value is wherever this is going, which is negative infinity. And we keep going up, and even though there's a gap here, it gets filled in. This gap here gets filled in. And then our very largest value looks like maybe 3.5. And it's closed because it's not filled in. Alright, so you give number 5 and 6 a try. You can pause it right now, and I'm going to give you the answer. There you go. You can see that even though we have holes here, they get filled in over here. Same thing here, those holes get filled in. Alright, so analytically, or algebraically, and some of this you're going to have to memorize, constant functions. Well, a constant function is pretty darn boring. Just looks like that. So if this was our x and y axis, what is the domain? Domain is all reals. Or negative infinity to positive infinity, another way to write that. Linear functions, kind of like that. What's the domain? Again, all reals. Absolute value functions tend to look like this. They are, domain is all reals. Range is not all reals for this one either, or this one. But the domain is. A quadratic function. Quadratics, well, if a is negative, it would look like that. The range is not all reals, but the domain is. Come on, negative infinity to positive infinity. Alright, so we need to look at these functions when we are answering the questions down below. So for the first function, x squared plus x minus 6 over x squared minus 4, looks like that. We want the function value at negative 2. So we go to negative 2, and well, what do we notice? They have what's called an asymptote right here. This thing's going to negative infinity, this one's going to positive infinity. This is undefined. How about negative 1? Negative 1, it's up here at 2. What conclusions can you make about these two computations? Well, domain is not all reals. Alright, you go ahead and try the next bit for g of x and h of x and check your answers. So you might want to pause it right now. Here you go. G of x, g of negative 4, g of 9, g of negative 11, h of 5. There you go. So let's take a look at the function itself without the picture. Where are there places it might come into problems with these two functions that we know just by looking at the graph that there's breaks or gaps? What kinds of things cannot be under a square root in the real number set, and what kinds of things cannot be on the denominator? So think about that as we turn to the next page. Alright, so given what we looked at just previously, hopefully you thought a little bit about what kinds of things cannot be in the denominator, and we're going to write it down, what kind of conclusion hopefully you came up with from the previous page. So the conclusion would be that denominator cannot equal 0 any place where, and I'm going to say h of x because h of x is in the denominator and it's shorter to write, where h of x is equal to 0, the function is undefined. So, for this problem, we want to know where the denominator is equal to 0. So let's set it equal to 0 and find out. X minus 3 times x minus 1, that's equal to 0. So zero product property says two numbers multiplied together. The answer is 0. That means 1, or the other of the numbers has to be 0. So we add 3 to this side, both sides, we get x equals 3. On this one, we add 1, we get x equals 1. These are the two places where the domain's going to have a problem. So the domain for this function, then, is going to be from negative infinity to 3, and then from 3 to 1, and then also from 1 to positive infinity. This one right here is not factored for us. We're going to have to do that to find out where the denominator is equal to 0. This is the difference of squares, so we have x plus 3, x minus 3 equals 0, so x equals 3, negative 3. Those are the two places that there's going to be a break in the domain. So the domain then is from negative infinity to negative 3, negative 3 to positive 3, and 3 to positive infinity. Alright, now we're going to factor this one. 2x squared minus 5x minus 3. We want that to be equal to 0. It's going to have to be 2x times x to get me 2x squared. And then two numbers that multiply together to get negative 3. I'm pretty sure that's it. Alright, so 2x plus 1 equals 0. X minus 3 equals 0. This is x equals 3. Subtract 1. 2x equals negative 1. Divided by 2, x equals negative 1/2. So these are the two places that the function is going to have a little hiccup. So the domain then is from negative infinity to negative 1/2, and from negative 1/2 to 3, and from 3 to positive infinity. There's the domain for that function. Square root functions. So square root functions, the argument, in this case we're calling it g of x, cannot be less than 0. It can be equal to 0, but not less than 0. So the conclusion that we can make, the argument, we're calling that g of x in this example, cannot be less than 0. It can be equal to, but not less than. So we want to know where is that line between positive and negative. So we're going to set x plus 3 equal to 0 and find out where that happens. So x is equal to negative 3, you're going to get 0. So then the domain, well, we want it to be bigger than, or do we want it to be less than 3? Let's see, if x is less than 3, we're going to get 2 plus 3 is 5. Oh, negative 3, that would be y. If we put a negative 3, if we put a negative 4, it's going to be negative. So we don't want anything less than negative 3. So we're going to have negative 3 and bigger. Oh, and we can include negative 3 because 0 is okay under a square root, just not negative. So you go ahead and do the next two and check your answers. So pause it right here. Alright, check your answers and we're going to go to the next page. So cube root functions, the domain is all reals as long as g of x is defined everywhere. So as long as the argument we're calling g of x is defined, I think that's how you spell it. That's definitely not how you should write it, is defined, then the domain is all reals. So as long as g of x is defined, so the domain of the cube root, I guess, would be the domain of g of x. That's how we should probably write that. I'll write that here. Domain of the function is equal to domain of g of x. That's a better way to write it. So where is x minus 3 defined? That is a line defined everywhere. So the domain is negative infinity to positive infinity, all reals. This one, where is 4 minus 2x defined? Everywhere. Again, that's another line. So the domain is negative infinity to positive infinity. Then we have to look at where is this one defined. It's defined everywhere as long as that is not equal to 0. 2x plus 1 equals 0. X equals negative 1/2. So the domain is negative infinity to negative 1/2, negative 1/2 to positive infinity. Oops, I needed a U in there somewhere. All right, there you go. Domain and range all in a nutshell. See you soon.